Namaskar, welcome to Exercise Explained. In this video, I would be solving question number 7 and question number 8, exercise 3B, machines, ICSE 10th physics. The previous questions have been done in the previous videos, the link for which will be provided in the description. If you like the video, do share it with your friends and consider subscribing to the channel. Starting with the 7th question. A pulley system has velocity ratio of 3. So velocity ratio given here is 3. Draw a diagram showing the point of application and direction of load, effort and tension. So since it was really difficult to draw it over here, I just imported an image. So this image shows a pulley system that has 3 pulleys. Obviously the lower the movable pulley will be less, the number of movable pulleys here will be lesser than the number of fixed pulleys. So we'll have 2 fixed pulleys in the top and 1 movable pulley at the bottom. The thread actually starts from here. So from here the thread starts, goes around the central pulley, comes down and then goes through the top pulley and finally comes out as an effort. So here it is given, it lifts a load of 150 newtons. So I can write here load is given as 150 newtons by an effort of 60 newton. Effort is given as 60 newtons and velocity ratio is given as 3. We need to calculate the mechanical advantage. So for finding mechanical advantage, MA will be equal to, the formula for mechanical advantage is load divided by effort. So we will get MA is equal to, the load is 150 divided by effort is 60, 0 cancels, 3 2s are 6 and 3 5s are, so we get mechanical advantage MA is equal to 5 by 2, that is 2.5. We have got mechanical advantage as 2.5. Now they have another very important question here. Is the pulley system ideal? Give reason. So in order to understand this, we need to find the efficiency. If the efficiency we get it as 100% or we get it as 1, it's going to be an ideal system, and if we do not get the efficiency as 1, it's not an ideal system. So here I would be using the formula of efficiency, that is mechanical advantage divided by velocity ratio. So we will be getting efficiency is equal to mechanical advantage, we just got it as 2.5 divided by velocity ratio is given as 3. To remove the decimal, we'll multiply numerator and denominator by 10. So we get efficiency is equal to 25 divided by 3 into 10 is 30. So we get the value of efficiency as 5 by 6. So efficiency we have got it as 5 by 6. Now 5 by 6 is equal to 0.83, or we can write it as 83%. So we have got the efficiency as 83%. So since efficiency is less than 100, we will write here, since efficiency is less than 1 or 100%, it is not an ideal pulley. So I hope this question is clear. Getting into the next question. Figure shows a system of 4 pulleys. The upper 2 pulleys are fixed. I would just write some numbers for the pulleys here so that it makes things clear for us. So this is 1, this is 2, this is 3, this is 4. Yeah. The upper 2 pulleys are fixed and the lower two are movable. So pulley 1 and 2 are fixed pulleys and pulley 3 and 4 are movable. Draw string around the pulleys, also show the point of application and direction in which the effort is applied. So it's very simple. We start the string from the top movable pulley, that is from this point right here. Now the string goes around pulley number 2 and then comes down to pulley number 3 and then goes to pulley number 1 and then finally comes to pulley number 4 and finally goes out as the effort. So there is a small mistake over here. The mistake is going to be the tension. So the tension is going to act in the downward direction here. Draw a string around the pulley, so we are clear with this. Now coming to the second part, what is the velocity ratio of this system? So straight away there are 4 pulleys, so the velocity ratio is going to be equal to, the velocity ratio is going to be equal to 4. The velocity ratio is 4. How are load and effort of the pulley system related? Now for finding this, we will have to find the mechanical advantage. So mechanical advantage will be equal to load by effort. Now load is going to be all the tensions that are acting except this one single tension here. Except this, rest all the other tensions. So how many more tensions do we have? 1, 2, 3, 4. So we have 4 tensions, so that is going to be the load. And the single tension which we did not consider over here, this tension, that is going to be the effort. So T and T cancels and we get the mechanical advantage as 4. Now that we have got the mechanical advantage as 4, now we know the formula. Again we will be using the same formula, that is mechanical advantage is equal to load divided by effort. So here load is going to be equal to effort goes to the other side, so we get mechanical advantage into effort. So the relation between load and effort happens to be L is equal to mechanical advantage, we just got it as 4, into effort. So this is going to be the relation between load and effort. So coming to the next one, that is D part. Now this is a common question. If this comes in any of the questions, the answer is going to be the same for most of it. What assumption do you make arriving at your answer in part C? So the first thing we assumed is it is an ideal pulley. So what do we understand by ideal pulley? We just discussed this in the last problem actually. Ideal pulley means 100% efficiency. After this, the second thing that we consider in all the problems of machines, that is no friction. That is the second thing. So the first thing that happened is ideal pulley. The next one is no friction. And the third thing is no mass, or we can call it as negligible or negligible mass. So that completes the 8th problem over here. So the next question onwards, that is question number 9 onwards, I would be doing in the next video, the link for which will be provided in the description. If you like the video, do share it with your friends and consider subscribing to the channel. So see you guys in the next video. Till then, Dhanyavad.